Okay, so here's our problem. Our problem is given in our formula in black, which is a quadratic equation. However, we want to solve it. And to solve it, what we need to do is convert it from our standard form into our intercept form. So once we've taken this, now what we're going to do is we're going to use what I like to call like the X or the diamond method. And what we're going to do that is we're going to make a little diamond, and we're going to put our value of C up top and our value of B on the bottom. And then what we're going to try to do is determine what values multiply to give me C, but then add to give me B. And those two values are going to be our P and our Q. So in this case, we kind of have some large numbers. And what we want to do to figure that out, to figure out what values multiply to give us C, we can figure out what the factors would be for C. Because there's only so many numbers that multiply to give you a negative 72. So we could say, well, 72 times negative 1, negative 1 times 72, right? These are all numbers that are going to multiply to give me negative 72. But out of these numbers, they have to add up to 14. OK, so therefore, we got that. Then we could do 36 times negative 2. You could do negative 36 times 2, right? Then we could do 3. So we could do 72 divided by 3. That would be 60, would be 10, so 14. So we could do, not 14, 48's 24. 24 times negative 3, and then negative 24 times 3. And then we could look at 4. And 4 is going to go into there as well. 4 would go into there 18. So you could do negative 18 times 4, and then negative 4 times 18. 5 is not going to go into there. 6 will go into there, though. 6 would go into there 12 times. So you could do negative 12 times 6, and then 12 times 6, or negative 6. And then you go 7. 7 does not divide into there. 8 does. So you could do negative 8 times 9, or 8 times negative 9. Now, these are all our factors that multiply to give us negative 72. And when you're doing factoring, what's so important, why you need to get a lot of extra practice, because out of all of these factors, there's only one of them that adds up to give us a positive 14. So we write negative 72 up here, and we write positive 14 right here. And I write the multiplication and say I need to figure out what numbers multiply to give me negative 72, but then add to give me 14. Those two values are going to be my P and my Q. So when looking at all these, you can write them all out. But the more and more you factor, the more and more you do this process, the quicker you're going to be able to do these in your head. So therefore, when I write all these down, I look at this and say, all right, what is the only values that add up to give me positive 14? And what you can see is there's my P and Q right here. Now, it doesn't matter which one is P, which one's Q, if you write them on the left or to the right. But I'll just write negative 4 and 18 right there. Therefore, that's my P and my Q. Remember, a equals 1, so this will be written as x minus 4 times x plus 18. So there you go, ladies and gentlemen. Now that's in our factored form. Now we can apply the zero product property. So we set both of these equal to 0. Then we solve for x. And there we go. Now we found our zeros, or our solutions, for our quadratic. Thanks.